I'm Jeremy Hines, Senior Electrical Engineer with Product Development at GPS Air. I'm here to talk about our newest technology, OptiLock, which is designed to increase a filter's ability to remove particles as they pass through the filter. The test rig consists of a duct designed to draw air through a filter while monitoring particle counts before and after the filter under test. Removal efficiency can then be calculated using real-time particle counts. In this demo, we focus on particles in the submicron range, specifically 0.3 to 0.5 microns, because most filters have difficulty removing particles in that range.
In this test run, the filter was able to remove approximately 34% of the 0.3 micron particles on its own. Once the baseline removal rate of the filter is established, we turn on the OptiLock device. As you can see, the filter's removal rate of 0.3 micron particles is increased to 55% by applying this technology, which equates to a performance increase of 61% versus the filter alone. If we look more closely at the data, we see that the baseline percentage removal rate of the filter was equivalent to a MERV 11 filter in the E1 bin. Once the OptiLock technology is applied, we see that we are able to increase the filter's MERV rating to a MERV 13 filter, which represents a significant improvement in performance. Thank you for watching. For more information about GPS Air and our technology, visit gpsair.com.
Hi, I'm Gary Fee, Director of Product Management here at GPS Air. As you know, we're committed to improving indoor air quality, and wildfire smoke events can have a significant impact on IAQ. According to the EPA, studies show that a major component of wildfire smoke is fine particulates, and frequently those in a submicron range. With that in mind, in this video, we're going to be talking about our new filter enhancement products and the test system that we used in order to develop the technology.
Hi, I'm Jeremy Hines, Senior Electrical Engineer with Product Development at GPS Air. I'm here to talk about the wildfire test rig we developed in order to evaluate the performance enhancement our OptiLock technology provides to air filters. This system allows us to generate real-world levels of wood smoke in order to simulate a wildfire event in a controlled manner.
The setup consists of the capacitor chamber, where wood samples are burned to generate smoke, mixing chamber, where smoke is mixed with ambient air to reduce the concentration to real-world levels. From the mixing chamber, air is drawn into the test duct, where we continuously monitor particles both upstream and downstream of the filter being tested. First step of the test is to process the wood sample down to small filings that allow us to burn the wood in a reliable manner. These filings are then placed in the capacitor chamber, where a heating element begins the burn process. Once the sample reaches sufficient temperature to begin smoking, we enable the control loop integrated into the system. The control loop modulates the flow of air into the barrel, which in turn regulates the smoke exhausted into the mixing chamber. The purpose of the second stage of the test rig is to bring the concentration of smoke in the duct down to real-world levels that would be seen during an actual wildfire event. This is accomplished by mixing the smoke from the middle chamber with the ambient air from our test facility. The real-world concentration we use in this iteration of the test is 150 micrograms per cubic meter and is based on data obtained from airnow.gov during a wildfire event. From the mixing chamber, air is drawn into the test duct, where we continuously monitor particles both upstream and downstream of the filter being tested. The real-time removal efficiency of the filter is measured before the OptiLock technology is enabled to establish a baseline. Once the baseline performance of the filter is determined, the OptiLock device is enabled and a new removal efficiency is calculated. Here are the results of a test completed using a MERV 14 filter with a smoke concentration of 150 micrograms per cubic meter. The filter shows a baseline removal rate of approximately 65% for the 0.3 micron bin of particles. By adding OptiLock, we were able to boost the performance of the filter to 85%. The additional capture rates represent a boost in performance of 32%.
As you can see, this testing shows how our filter enhancement technology can have a significant impact on improving a filter's ability to remove submicron particles found in wildfire smoke. We're excited to introduce these products as part of a multi-layered approach to mitigating wildfire smoke events. For more information, please visit us at gpsair.com. Hi, I'm Gary Fee, Director of Product Management here at GPS Air. In this video, we're going to demonstrate the effects of the interaction between MPBI-generated ions and smoke particles in the air. For apparatus, we have a 6-inch acrylic tube which is divided into 2 equal volumes. One side will serve as a control, showing how the smoke naturally reacts, and the other is fitted with a DM2 ionizer, which is mounted on a flexible DMS saddle. We will use a smoke generator that uses a glycol-based solution to serve as a surrogate for natural smoke. We'll fill each side individually. First, the control volume. And then for the ionizer volume. And we'll just overfill this a little bit to make sure that we have at least as much smoke in as in the control volume. We'll turn the DM2 on and then rotate the apparatus to make sure that you can see each volume equally. And so we can see the volume that's been treated by the DM2 has virtually cleared now. The control volume will eventually dissipate, but it's going to take a very long time. You can see now we can't see through the control volume, but you can see the DM2 device at the back of the chamber that's being treated. Okay, thank you for watching this video. And if you have any questions, please visit us at gpsair.com.